So this particular class I want to discuss a few questions based on monotonic function, that means increasing and decreasing functions. See, this is the first question. F of x is equals to x plus 1 whole cube into x minus 3 whole cube, where this function is strictly increasing, where this function is strictly decreasing. We have to find out. Come on, find out f dash of x. F dash of x is equals to x plus 1 whole cube into x minus 3 whole cube, differentiation is 3 into x minus 3 whole square plus x minus 3 whole cube into x plus 1 whole cube, differentiation is 3 into x plus 1 whole square. Now what we can take common? You can take 3 into x plus 1 whole square, we can take common. Next, x minus 3 whole square also we can take common. Then what left? Here we took x minus 3 whole square into 3 common, x plus 1 whole square also common, then we got x plus 1, right? Next again, x plus 1 whole square common, 3 into x minus 3 whole square common, then we got x minus 3. Now this simplification is nothing but 6 into x plus 1 whole square into x minus 3 whole square. So 2x minus 2, if you take 2 common, x minus 1. Now you can observe this total expression f dash of x, positive or negative, depends only on this particular term. F dash of x is a positive or negative depends only on this particular term, because square always positive, square always positive. That's why we have only number 1. So this is, that side will get plus and this side we are getting negative. But wait, so this is somewhere here we have a point x is equal to 3, and somewhere here there is a point we have x is equal to minus 1. So for the function to be strictly increasing, f dash of x must be greater than 0. But f dash of x greater than 0 means positive. Where positive symbol is there? From 1 to infinity we have a positive symbol is there, except at 3. That 3, f dash of x is becoming 0. So that's why we can write 1 to 3 union 3 to infinity. In this interval the function is strictly increasing function. Next, for the function to be strictly decreasing function, f dash of x must be less than 0. Where negative symbol is there? From minus infinity to minus 1, because at minus 1 it becomes 0. Minus infinity to minus 1 union minus 1 to 1. In this interval the function is strictly decreasing function, whereas in this interval the function is strictly increasing function. So this is another question they have given. F of x is equals to log of 1 plus x, log of 1 plus x minus 2x divided by 2 plus x, x greater than minus 1. When x values are more than minus 1, that function is, we have to show this function is an increasing function. Okay, differentiate this one. F dash of x is equals to log of 1 plus x, differentiation 1 by 1 plus x minus, here we have to apply u by v rule, 2 plus x into 2x, differentiation 2 minus 2x into 2 plus x, differentiation 1 divided by 2 plus x whole square. Now this further simplification we can do it like this: 2 plus x whole square minus 1 plus x into, what about this simplification? Plus 2x minus 2x cancelled, 4 divided by 1 plus x into 2 plus x whole square. So now further simplification we can write 4 plus x square plus 4x minus 4 minus 4x divided by 2 plus x whole square into 1 plus x. Now you can observe here, plus 4 minus 4 cancel, 4x also cancel. This is always greater than or equal to 0. The reason is square of a number always positive, 1 plus x also positive. The reason is logarithm is defined only for positive real numbers. 1 plus x greater than 0. That is given in the information x greater than minus 1. So this is a positive. This is also positive. So this is x square greater than or equals to 0. That's why f dash of x greater than or equals to 0. So we can say the function is an increasing function. So the question is given like this: y is equals to 4 sin theta divided by 2 plus cos theta minus theta. That is y is an increasing function. We have to show in the interval 0 to pi by 2. If theta belongs to closed interval 0 comma pi by 2, that function is an increasing function. Okay, find out differentiation. dy by d theta is equals to u by v rule. So we'll get 2 plus cos theta into 4 sin theta, differentiation is 4 cos theta, minus 4 sin theta into 2 plus cos theta, differentiation minus sin theta, whole divided by 2 plus cos theta whole square minus theta, differentiation is 1. Now further simplification, we will get 8 cos theta plus 4 cos square theta plus 4 sin square theta, 2 plus cos theta whole square, we are taking LCM, minus 2 plus cos theta whole square divided by 2 plus cos theta whole square. Now check the simplification here. 8 cos theta plus 4, because cos square theta plus sin square theta is equals to 1, minus, what about this expansion? 4 plus cos square theta plus 4 cos theta divided by 2 plus cos theta whole square. Now this further simplification, plus 4 minus 4 cancel. 8 cos theta minus 4 cos theta, you will get 4 cos theta minus cos square theta divided by 2 plus cos theta whole square. Numerator we can take cos theta common. If you take cos theta common, what we will get? So cos theta common, we will get 4 minus cos theta divided by 2 plus cos theta whole square. Now you can observe, no doubt this is always greater than or equals to 0, because the first information is 4 minus cos theta. Cos theta maximum value is 1. From 4 the maximum you can subtract is 1. So that's why this value is always positive. Square of a number is always positive. At the same time, between 0 to pi by 2, first quadrant. In case of 0 or in case of pi by 2, it becomes equal to 0. Between 0 to pi by 2, this value is also positive. That's why we got dy by d theta greater than or equals to 0. So the function is an increasing function in the interval 0 to pi by 2. So this is another question. F of x is equals to x square minus x plus 1. F of x is equal to x square minus x plus 1 in the interval minus 1 comma 1. It is neither increasing nor decreasing function we have to show. Observe here, f dash of x is equals to, its differentiation is 2x minus 1, right? For the function to be strictly increasing function, f dash of x greater than 0, so 2x minus 1 greater than 0, therefore x greater than 1 by 2. So what we can say, from 1 by 2 to 1, the function is increasing function. Next, for the function to be strictly decreasing function, f dash of x less than 0, 2x minus 1 less than 0, therefore 2x less than 1, so we are getting x less than 1 by 2. That means from minus 1 to 1 by 2, in this interval the function is strictly decreasing function. In this interval the function is strictly increasing function. What he is asking, between minus 1 and plus 1, somewhere here minus 1 by 2 is there. Between 1 by 2 to 1 we got an increasing function. Between minus 1 to 1 by 2 we got a decreasing function. Now what can you say in the entire interval? from minus 1 to 1, the function is neither increasing nor decreasing function. So here the question is given like this, f of x is equals to cos x given, and another function is also given, f of x is equals to cos 2x is another function, and f of x is equals to cos 3x is one more function, and f of x is equals to tan x. These are the four functions given, and the interval is given from 0 to pi by 2. In the interval 0 to pi by 2, which function is strictly decreasing is asking. Among these functions, which functions are strictly decreasing in the interval 0 to pi by 2? Okay, right. What about f dash of x in this case? F dash of x is equal to minus sin x. As we know that x belongs to 0 to pi by 2, first quadrant, sin x, no doubt, greater than 0. But sin x greater than 0 means minus sin x less than 0. Therefore, we are getting f dash of x less than 0. Therefore, in this interval, this function is strictly decreasing function. So, this is correct. Next, the second case is what? F dash of x is equals to cos 2x differentiation minus sin 2x into inner function differentiation 2. Right? So, 0 less than x less than pi by 2 is the given information. Now, multiply with 2. 0 less than 2x less than pi. Now, between 0 to pi, sin 2x is greater than 0. Now, we can write minus 2 into sin 2x is less than 0 or not, because multiplied with minus, that's why inequality changes, which is nothing but f dash of x less than 0. But f dash of x less than 0 means we can say the function is strictly decreasing function. Yes, this is also correct. The function is strictly decreasing function. In these two cases, we got function is strictly decreasing function only. In the other case, f of x is equal to cos 3x given. What about f dash of x minus sin 3x into 3? Now, 0 less than x less than pi by 2. 0 less than x less than pi by 2 means 0 less than 3x less than 3 pi by 2. Now you can observe between 0 to 3 pi by 2. This is the interval between 0 to 3 pi by 2. Now here I am dividing that interval into 0 less than 3x less than pi by 2, and next one is pi by 2 less than 3x less than 3 pi by 2. Like that I divided. Why I divided like this? Here sign is positive. No, here it is. Yes, here we can write from 0 to pi we can write. So 0 to pi, whereas here pi to 3 pi by 2. Right. So 0 less than 3x less than pi, in this interval sign is positive. That's why we can write sin 3x greater than 0. Whereas here what happens? Sin 3x is less than 0. Next what we can say? Sin 3x greater than 0 means minus sin 3x. We are multiplying with a negative number, that's why less than 0. So we got f dash of x less than 0. That means in the interval 0 to pi, 3x value lies between 0 and pi means what about x value? 0 less than x less than pi by 3. So for these values the function is decreasing function, but whereas here sin 3x less than 0 means minus 3 into sin 3x must be greater than 0. Therefore we are getting f dash of x greater than 0. So 3x lies between pi and 3 pi by 2 means pi by 3 less than x less than pi by 2. So overall what we got the information? So this is 0 and we have pi by 2. In between pi by 3 is there. So between 0 to pi by 3 we got strictly decreasing function. Between pi by 3 to pi by 2 we got strictly increasing function. Therefore, in the total interval 0 to pi by 2, the function is neither increasing nor decreasing function, not a monotonic function. Next one is, this is the another one, f of x is equals to tan x. Yes, f dash of x is equals to tan x differentiation is secant square x. Yes, this is always greater than 0 in this interval. When f dash of x greater than 0 means the function is strictly increasing function in the interval 0 to pi by 2. So total 4 functions given. Among those 4 functions, this function and this function, this is neither increasing nor decreasing in the interval 0 to pi by 2. That means it is not a monotonic function. Whereas f of x is equal to tan x is strictly increasing function. But he is asking in the question, which of the following functions are strictly decreasing functions? First and second functions are correct. So the next question is given like this: I be any interval disjoint from closed interval minus 1 comma 1. So what is the meaning for that? I be any interval disjoint from this. This is the meaning. Now here this is a minus 1 and here we have plus 1. I be any interval disjoint from this. I be any interval disjoint from this. This is the given interval. Now we can take our interval I as this one. This portion represents I from minus infinity to minus 1. This is a minus infinity and this is a plus infinity. That means in this interval we have to show. He is talking about this interval. This is I. I be any interval disjoint from this. I be any interval disjoint from this means this is our interval I. In this interval, he is asking to show about this function f of x is equal to x plus 1 by x is a strictly increasing function he is asking. In this interval, the function is strictly increasing, we have to prove. Okay, f dash of x is equals to 1 minus 1 by x square. Now we can write this one as x square minus 1 divided by x square, that is equals to x plus 1 into x minus 1 divided by x square. For the function to be strictly increasing, f dash of x must be greater than 0. Now what happened this one? This is a minus 1 and this is a plus 1, plus minus plus. Greater than 0 means because this expression is a positive or negative depends on the numerator only. So greater than 0 means we have to consider the positive portion. This is the positive portion from minus infinity to minus 1 union 1 to infinity. In this interval, this is nothing but the interval disjoint from this. In this interval, the function is strictly increasing function. So this is the another question. F of x is equals to x square into e to the power of minus x is a strictly increasing function. F of x is equal to x square into e power minus x is strictly increasing function which interval. So find out f dash of x. F dash of x is equal to x square into e power minus x into minus 1 plus e to the power of minus x into x square differentiation is 2x. Now if you take e to the power of minus x into x common, then what we will get? E power minus x into x common, then we will get 2 minus ex. Right? So this we can write it as, for the function to be strictly increasing, f dash of x must be greater than 0. F dash of x greater than 0. Therefore we will get e to the power of minus x into 2 minus x must be greater than 0. Therefore we are getting x into x minus 2 less than 0. Because e power minus x is always positive removed. Here minus taken common, that's why inequality changes. Now number line, this is 0 and here we have 2 plus minus plus. Less than 0 means negative portion. Negative portion is there between 0 to 2. That's why in this interval the function is strictly increasing function. So this is the another question. F of x is equals to tan inverse of sin x plus cos x. F of x is equals to tan inverse of sin x plus cos x is a strictly increasing function in the interval 0 to pi by 4. this function is strictly increasing function in the interval 0 to pi by 4 we have to show. Okay, right. F dash of x is equals to tan inverse x differentiation 1 by 1 plus x square sin x plus cos x whole square into inner function differentiation. Sin x differentiation is cos x minus cos x differentiation is sin x. Now we got the information. F dash of x is equal to cos x minus sin x by 1 plus sin x plus cos x whole square. You know very well the graph of sin x and cos x. Now this is the graph of sin x in the interval 0 to pi by 2, or this is the graph of cos x in the interval 0 to pi by 2. Now you can observe this particular point is pi by 2, where sin x and cos x graphs are intersecting, that is pi by 4, and this is 0. Now this is the graph of cos x and this is the graph of sin x. Tell me, in the interval 0 to pi by 4, this is the 0 to pi by 4. In the interval 0 to pi by 4, cos graph is dominating or not? Cos graph is dominating means cos x has more values or not? Cos x graph, and this is sin x graph in the interval 0 to pi by 4. That's why no doubt cos x is greater than sin x in the interval 0 to pi by 4. That's why cos x minus sin x is greater than 0. So we are getting f dash of x greater than 0 in this interval. So the function is strictly increasing function from 0 to pi by 4. So this is the another question. F of x is equals to sin x plus cos x. F of x is equal to sin x plus cos x in the interval 0 less than or equal to x less than or equals to 2 pi. He is asking which interval the function is strictly increasing, which interval the function is strictly decreasing. Okay, right. Find out f dash of x. F dash of x is equals to sin x differentiation is cos x minus cos x differentiation is sin x. F dash of x we got cos x minus sin x. Now I am drawing the graph of sin x and cos x in the interval 0 to 2 pi. That is the graph of cos sin x in the interval 0 to 2 pi. This is 0 and here it is pi by 2. You will get the maximum value 1, and this is a pi, it becomes a 0, and this is 3 pi by 2, and finally at a 2 pi again sin we got 0. Now this is the graph of cos x. At 90 you will get 0, at 180 you will get a minus 1, at a 3 pi by 2 you will get 0, again at 2 pi it reaches to maximum value 1. Okay, but where these two graphs intersect, this is one particular point where they are intersecting, that is nothing but pi by 4, and this is one more point where they are intersecting, that is nothing but pi plus pi by 4, which is nothing but 5 pi by 4. So clear, this is the graph of sin x and this is the graph of cos x. Now tell me, in the interval 0 to pi by 4, 0 to pi by 4, observe the graph, because at pi by 4 this value is becoming 0, at a 0 you are getting positive only, right? 0 to pi by 4, cos graph is dominating, that's why cos graph is dominating between 0 to pi by 4. Again where cos graph is dominating, you can observe again from pi by 4 to 2 pi, this is the graph of cos x, has the dominating values. Cos x graph where from 5 pi by 4 to 2 pi, 5 pi by 4 to 2 pi, that's why closed interval 0 to pi by 4 union 5 pi by 4 to 2 pi. For these values, no doubt you can check f dash of x we are getting greater than 0. F dash of x greater than 0, because closed 0 I took, when x is equal to 0 you are getting greater than 0. At x is equal to 2 pi also we are getting greater than 0. F dash of x greater than 0 for these values. This is not 5 pi by 2, it is 5 pi by 4. But what happens for the other values? Again you can observe from 5 by 4 to pi by 4 to 5 pi by 4. If x values are there between pi by 4 to 5 pi by 4, for these values in this interval, which graph is dominating? From pi by 4 to 5 pi by 4, sin x graph is dominating. Sin x has more values. But sin x has more values means this is negative or not. That's why we are getting f dash of x less than 0 in this interval. So in this interval the function is strictly decreasing function, whereas in this interval the function is strictly increasing function. So that is about the first level problems on monotonicity, that is increasing and decreasing function. Next class we will discuss more questions on increasing and decreasing functions. Okay, bye bye.